Hello everyone, and this is a recording of 3.3, the inverse of a quadratic function. So I'm going to have three separate videos, one for example 1, one for example 2, and one for example 3. But first, recall from chapter 1 that inverse functions are a special class of functions that undo in each other, and the inverse of a function can be found by interchanging the domain and range of the relation for the whole function or relation. And for the individual points, we can swap x and y. And when we also try to find the equation of our inverse, we would swap the variables and then re-isolate for y. We did that for linear functions and relations, and we're going to do the same thing for quadratic functions and relations. So I'm going to read the question here. Make sure you have your handout in front of you, because then I'm going to be doing the question on the full grid so that you can see it more clearly. So example 1a asks us to graph the inverse function. So anytime we're asked to graph the inverse, it's always helpful to graph our parent. And because, as we know, all of us are chapter 1 experts by now, I'm just going to do a quick graph over here. I've got my x and y axis, and my equation is just x squared plus 4, so I know that it's my original parent function of x squared just shifted up 4 units. So let me label my graph here very quickly. 4 and 4. I'm not going to label the negative side for now, but my vertex is right here, and then my step pattern is 1 and then 3 for each side. So this is the parent function, and now I can graph my inverse multiple ways, but the easiest way is just to look at our points. So you look at the coordinate setup for each of the points. Our vertex is going to be what? 0, 4. Then our next point would be 1, 5, and the next one's going to be 2, what? 8. And because we're swapping our domain and range for our inverse function, which I'm going to write and graph in red, it becomes 4, 0, 5, 1, and 8, 2. Now, I'm just going to plot those points. So I've got 4 and 0, 5 and 1, and then 2, 6, 7, 8 and 1, slightly past where, oh, sorry, not 8 and 1, 8 and 2, so ignore this point here. I will ignore it, don't worry, when I graph my relation. And remember, now our axis of symmetry is no longer vertical, it's horizontal. And you'll notice that here, once I've finished graphing, so let me just graph it here, I've graphed my inverse relation, and I notice that it fails the vertical line test, right? Because only in this point do I only have one y value for an x value. From this point forward, as my x gets more positive, I'm always going to have two y values for every x value, so it fails the vertical line test, and that's why it's an inverse relation, not an inverse function. So that's one way to graph it. Another way you can graph it is if you're more visual with graphs. You can remember that an inverse is just a reflection of our function or relation, whatever it is, through this line right here. Let me just draw it, and then I'll recenter the page for you. This diagonal line of y equals x. So if it helps more visually for you, you can see how it's reflected through that line. But this is the easiest way to do it. Okay, so that was part A. Part B asks us to state the domain and range of both the original function and the inverse relation. So I'm going to write in blue for our original function. We've got our domain, that x is an element of the real numbers, and let's see if I have any restrictions. I don't, right? There's no value for which my function is going to be undefined. I can go all the way to the left toward negative infinity, all the way to the right toward positive infinity, so my domain does not have restrictions. However, my range, still an element of the real numbers. However, you notice that because this is our minimum, I'm never going to get past or lower than the value of y equals 4. So I'm going to have I'm going to have that y has to be greater than or equal to positive 4. Okay, versus my inverse, whose domain is that x is still an element of the real numbers, but now x has to be greater than or equal to 4, right? Because this is as positive as x, or sorry, this is as negative as x gets. It doesn't go any farther to the left, but it does continue on to the right. So x has to be greater than or equal to 4, and our range now has no restrictions, right? Because I can go all the way up and all the way down on my y values, okay? And now, like I actually said, so spoiler alert, I suppose, for C, it asks us to determine whether the inverse is also a function and then state its equation. So the first part, like we said, because we've graphed, we see that it fails the vertical line test. So right off the bat, we can say it is a relation. And for the second part, like I mentioned right at the beginning of this lesson, what we do for linear equations, we also do for quadratic equations. If I need to find, so if I'm given f of x, and I'm asked to find the equation of the inverse of f of x, which is notated this way, where f is to the power of minus 1 of x, I just need to take my original, so I've got f of x is equal to x squared plus 4. So that's just another way of writing y is equal to x squared plus 4. I swap those variables. So I'm going to do a little arrow here, and I'm going to swap. I'm going to make it x is equal to y squared plus 4. And now I need to re-isolate for y. So the first thing I do is subtract. I'm going to color code it actually. I'm going to go with green. I'm going to subtract 4 from both sides. So I'm going to have x minus 4 here. Careful, I wrote it underneath because I didn't have room, but it's not division. These cancel out, so then I'm left with x minus 4 is equal to y squared. And now when I get rid of my square over here, or my power of 2, I just need to square root both sides. But remember, when you square root both sides, these two will cancel, so I end up y is equal to plus or minus the square root of x minus 4. And that's what gives us our top half over here and bottom half over here, and that's what makes it a relation instead of a function. Okay, so that's the whole question. So follow, or not follow, but click on the next video for example 2.